anyone should feel free to interrupt me at any time with any questions you have or comments you want to add.
Real quick, is this getting recorded? Just so I know whether to record it.
Bentley.
Cool.
Perfect. Okay, so today we're talking about ReWOO. I've had a lot of people contact me about this paper over the last few weeks. It's definitely probably the most significant paper since Voyager, in my view, in terms of specifically the kinds of things we're trying to do in AutoGPT. It's a pretty significant step forward in reasoning, as we'll see. It really allows agents to be more flexible and plan ahead to a greater degree than the current state of the art. So, ReWOO and the prior work that it's building on is all about augmented language models, so ALMs. And ALMs blend the reasoning capabilities of LLMs with tools, and those tools can allow the LLMs to do knowledge retrieval and execute actions. So, things like Toolformer, Voyager, AutoGPT. Specifically, with an ALM, the LLM uses its reasoning to call an external tool, then gets halted, waiting for the tool's response, and then once the tool's response comes back, it decides on the next action based on all of the preceding response tokens. So there's a lot of waiting, and most of the time the LLM is essentially waiting for the tool to respond. It can only go one step at a time. It can't move on to the next step until it gets the value returned from the previous step that's waiting on. So ReWOO addresses this problem for the first time, proposing a modular paradigm. So ReWOO stands for reasoning without observation. ReWOO detaches the reasoning process from the external observations. So by external observations, they mean the results of tools and external knowledge base calls. And this ability significantly reduces token consumption overall. So, notably, over the current state of the art, ReWOO achieves 5 times more efficient token usage and has a 4% accuracy increase on a specific natural language benchmark they use, compared to this current state of the art, which is React, which is essentially the one step at a time model I just described. So ReWOO also builds on the current state of the art by demonstrating a greater robustness to tool failure, which is extremely common with all augmented language models at this point. It's so early on, and the LMs have not really learned, or we've not really learned how to convey tools correctly to them. So oftentimes tool failure with the current state of the art is catastrophic and essentially ends that chain of thought for the LM. So beyond just the prompt efficiency, ReWOO also decouples the parametric modules from the non-parametric tool calls, which enables instruction fine-tuning end-to-end throughout the entire LLM. And it also allows them to fine-tune smaller LLMs to offload certain tasks, which significantly reduces the compute needed to achieve certain tasks. So the illustrative example they have in this paper is they offload significant reason work from GPT 3.5 Turbo to a 7 billion llama model, and they also fine-tune the llama model to get a planning-specific smaller model. So their work here on a higher level demonstrates the potential for really efficient and scalable smaller models that are fine-tuned for the specific task at hand if you know what your domain is going to be beforehand. So AutoGPT gets a shout out here, which is they mention as a prevailing application of the current state of the art of augmented language models. And projects like AutoGPT and really the prevailing current paradigm for prompting with augmented LLMs is the React model, where essentially the LM calls one tool at a time and then waits for the response and goes one step at a time. So this, of course, introduces frequent execution and suspension of LLMs. So there's a lot of redundant context being sent every single call because you have to provide the full context every single call. even though in between those calls, most of the context is shared. So that leads to a lot of large token usage and a fairly inefficient utilization of your tokens. So in figure 1, this is a good example of, at the high level, what ReWOO is doing. So on the planner side on the left, you can see that it sets out its plan and is able to essentially assume or, assume what a potential response might be, and then what its next question based on that response might be. So even though it doesn't make the tool calls, it's able to realize that, for example, in figure 1, once it searches for information about the hinchata, which is a kind of drink, and it knows it wants to make, or it knows it wants to find out what the cognac house that makes the main ingredient for hinchata is. It knows that once it finds any information about hinchata, the next thing it would want to know is what is the main ingredient. And then once it knows the main ingredient, it wants to search for more information about that main ingredient. And then it wants to find out who makes that main ingredient. So even though it doesn't know what the main ingredient is, it's able to go through the logic and essentially look forward into the future about the kind of calls and questions it would have once it gets the incremental information back. So then that plan is passed to a worker, and the worker then goes through all the steps. And because the entire plan is already set out, it reduces the need to send redundant tokens continually. So the fact that the plan has already been created several steps out allows the worker to be more efficient in executing the plan. So given a question, the planner component of ReWOO composes a comprehensive blueprint of interlinked plans, and this is all prior to any tool responses. Then this blueprint is given to the worker, and the worker then uses external tools to collect evidence. Then finally, the plans and evidence are paired together and fed to the solver. So the solver essentially interweaves the plan and the evidence, and is then able to go through the logical reasoning process to find the correct answer. So what this allows is you only have one call at the very end for the solver that includes all of this context. So that's a huge reduction in token usage compared to the current state of the art. So ReWOO compartmentalizes the key components of an augmented language model. The key components are a stepwise reasoning, then the tool calls, and then finally the summarization. And these components are split into the 3 modules of planner, worker, and solver. The planner breaks down the task and formulates a blueprint for a blueprint of independent plans. Each component of that plan is then allocated to an individual worker. The worker then retrieves knowledge from tools to provide evidence. So each worker, I'm pretty sure, is only getting one component of the plan overall. So if the planner comes up with a step or a plan that has 4 components, 4 individual workers would then be spawned, and they would each go find their one little piece of information, and then the plan and all those smaller pieces of information would be compiled together and then given to the solver. So the solver then synthesizes all the plans and evidence to generate the ultimate answer for the initial task. So ReWOO separates the reasoning process from external tools, avoiding the redundancy of interleaved or redundant prompts and information that is sent over and over. That is pretty inherent to the current state of the art, which is observation-dependent reasoning, where the next reasoning step is dependent on the most recent observation. So because of this, ReWOO significantly reduces token usage and enhances prompt efficiency. So the evaluation baseline they use to compare ReWOO against current state-of-the-art or past paradigms for prompting include 2 non-ALM prompting methods, both direct prompting, which is just basic prompting, and then chain of thought prompting, where you elicit from the model, think step by step, and reason out your plan. And then they also compare ReWOO against the prevailing augmented language model paradigm, which is ReACT, which is an observation-dependent reasoning. This was an interesting footnote at the bottom. they mentioned that the current paradigm of observation-dependent reasoning can bring substantial cost to average users, and one of their footnotes suggests that a single multi-step multi-step task to solve with AutoGPT easily exceeds $1 in API costs, which I guess I've not personally experienced, except for using GPT-4, but that's not most users. I thought it was an interesting note. So for figure 2, on the right side, they're comparing against the current state of the art, which is reasoning with observation. And on the right, in systems like React, the observation-dependent reasoning, the task requested from a user is first wrapped with context, and then fed into the LLM to initiate a reasoning process. The LLM then generates a thought and an action, and then waits for the observation from the tool. The observation is then stacked onto the prompt history to start the next LLM call. So there's a lot of waiting in between those tool responses. In contrast, in ReWOO, the planner produces all at once a list of interdependent plans and then calls a worker to fetch evidence from tools to fill in each of those planned action calls. And then the plan and the evidence is fed together and given to the solver. So they observed that a 7 billion parameter llama fine-tuned model with small learning epochs can be on par with GPT 3.5 in a zero-shot prompting scenario, which underscores the ability of ReWOO to facilitate lightweight and scalable augmented language model deployments. So their specific contributions to the field in ReWOO, they show that they identify the reasoning and assess the reasoning ability of LLMs without explicit observations, which they term foreseeable reasoning. So that's specifically the skills that we see in the prompting or in the planning component of ReWOO, where the LLM is able to put together a multi-step plan, even though it doesn't know the intermediate observations that will be required to actually execute the plan. And building on that, they introduce a modular framework they call ReWOO, which is designed to capitalize on the foreseeable reasoning ability of LLMs. Then they finally demonstrate a pipeline to offload the general ability of foreseeable reasoning from LLMs into smaller language models, which enables a smaller model to utilize unseen tools in zero-shot setups. So it is quite generalizable. So a salient ability of humans is to predict possible outcomes from to-be-conducted actions. The foreseen outcome of action usually turns out to be instructive enough for adapting and planning for the next steps. So humans are able to foresee likely outcomes from their actions even before they've done them, which is essentially what they're trying to elicit from an LLM in the ReWOO framework. So in ReWOO, the planner leverages the foreseeable reasoning of LLMs to compose a blueprint. This planner paradigm enables ReWOO to tackle multi-step and complex tasks, particularly those where a subsequent step depends on observations from prior steps. So ReWOO is able to solve tasks that are where each step is very closely intertwined to the previous one, even though at the planning stage it won't know the actual observations that interconnect those different tasks. So the worker then enables ReWOO to interact with the environment through tool calls once the plan has been created. So the planner provides a blueprint, and then designated workers are invoked with the instructions from the plan, and then they populate the evidence slots within the plan. Then once the evidence has been incorporated into the plan and the evidence is given to the solver to formulate a solution. So when they're prompting the solver, they use provided plans and the evidence, and they tell the solver to utilize both with caution, and that prompt to use the plan and evidence with caution enhances the overall performance of ReWOO. They attribute this improvement to the solver's inherent reasoning ability to resolve simple tasks or partially compensate for failures in the planner worker. Later on, we'll see that ReWOO is much more robust against, or much more robust in the situation of tool failure compared to the current state of the art of observation-dependent reasoning. So the specific equations are not super important, but equation 1 here suggests that duplicating identical prompts are used as input redundantly in the current state of the art, which is observation-dependent reasoning. So as the input tokens are usually non-trivial, or specifically the context and exemplars are typically non-trivial numbers of tokens. Input tokens grow quadratically as the number of steps of the task increases. So very quickly, a observation-dependent reasoning framework scales beyond the context window of current LLMs, so it's simply not possible to accomplish long, multi-step, complex tasks based on the current state of the art. So their mathematical analysis about token growth based on the number of steps suggests that a task sent to an augmented language model, as it becomes increasingly complex, thus introducing more reasoning steps, ReWOO can save substantially larger numbers of tokens and computation costs compared to the current state of the art. So ReWOO's benefit over the current state of the art only grows as the complexity of the task that it's trying to solve increases. So a common concern of augmented language models is that they bind parametric language models with non-parametric tool calls, and the fact that the language model is parametric, but the tool calls are not, complicates the ability to end-to-end training, so essentially fine-tuning on the tool calls and the language model's ability to learn how to call tools. So ReWOO decouples the tool calls from the observations, which allows them to optimize the generic ability of the LLM's ability to foresee reasoning on a planner module. And this is because there's no tool response exposed to the planner module during fine-tuning. This was inspired by recent specialization framework, which is prior work in the literature. They attempt to elicit foreseeable reasoning from GPT 3.5 and offload that reasoning into a Llama 7 billion model. This is a similar paradigm to how Alpaca was fine-tuned. Alpaca was a fine-tuning of Llama based on outputs from GPT 3.5. So they fine-tune Llama on Alpaca, and then they take Alpaca and fine-tune it further on the specific planner instruction data to obtain a 7 billion parameter planner model that specializes in foreseeable reasoning. So the 7 billion parameter model is essentially a ReWOO specific planning module that is able to do foreseeable reasoning to a greater degree than other more generic fine-tuned models. So they assess this potential of specialization on multiple benchmarks, and they do some studies replacing the ReWOO planner with GPT 3.5, Alpaca, and the planner 7 billion model. So when they were choosing datasets for the experiments, they emphasized or prioritized using test sets that required the ability for the LLMs to use external tools. So they curated a dataset where answering the questions correctly requires up-to-date external knowledge. So notably, ReWOO is not only consistently able to reduce the token usage compared to the current state of the art, but even matches or outperforms React in all tasks. So it's much more efficient while either maintaining or improving upon the current state-of-the-art ability. So they use a few different data sets: hotpot, trivia, sport understanding, which is these are all question and answer tasks on different domains. Strategy, QA, requires multiple steps of reasoning. They also have some grade school math problems, some high school physics questions. They also, to try and challenge the augmented language models to be able to use up-to-date knowledge, they created a specific question-answer dataset over the 2023 State of the Union address, which, if you're not from the US, the State of the Union is a speech the president gives to the legislature once a year. So, for example, a question might be, is the Speaker of the House, which is the head of one of the legislative branches, are they older this year than last year, which requires the augmented language model to be able to discover who the Speaker of the House is this year as well as last year, and then compare their ages. So that requires the ability to effectively utilize or find and utilize external information. They also curate another set of tasks which specifically include tasks that align augmented language models with real-world situations. For example, recommending restaurants to individuals, stock trading, AI drawing, etc. Tasks that are much more realistic simulations of what an augmented language model would be used for in real life compared to a lot of the current popular natural language processing benchmarks, which are often quite abstract and don't really indicate the augmented language model's ability to perform everyday tasks that normal users would use it for. So they go over a little bit more about the other prompting methods they use. We've talked about chain of thought prompting a lot in the past, so I don't think it's worth going over. They provide a large range of tools for the augmented language models to use in order to retrieve knowledge and interact with their environment. So they give it the ability to search Wikipedia, search Google, use Wolfram Alpha, which can do both search and as well as really computation is probably the most powerful thing that the Wolfram Alpha API exposes to the LLM in this case. They also give the augmented language model access to a non-augmented large language model, so it could theoretically create and spawn sub-agents. They also give the augmented language model access to a calculator, and then for the State of the Union question specific, they also give it the ability to search a document where that document is the text of the State of the Union. So for scoring the correctness of responses, they use a GPT-4 based score to measure the semantic accuracy of answers from these augmented language models. So for fine-tuning, they fine-tune a 7 billion parameter Llama model on a single RTX 4090 using LoRa, which is quite impressive considering the RTX 4090 only has 24 gigabytes of VRAM. For fine-tuning a model that is this capable, that's quite a small or limited amount of compute power. So I was impressed they were able to do that. I wonder how many days it took. I imagine many. So under the augmented language model setups they just described, they observed that ReWOO wins over React. There's the current state of the art in all benchmarks. Averaging over 6 public benchmarks they choose, ReWOO is able to reduce token usage by 64%, with an absolute accuracy improvement of 4.4% over React. So these great results imply the success of ReWOO in eliciting foreseeable reasoning ability and capabilities from LLMs, as well as the significant efficiency boost of ReWOO against prevailing observation-dependent augmented language model systems. So then on the curated task, which is the State of the Union question and answer task, ReWOO outperforms React by 8% in terms of accuracy and consumes 43% less tokens. So they believe this kind of question and answer on a document is more closely related to real-world applications for ALMs than other preceding public natural language benchmarks. So they found, so this is table 2, and really the interesting parts of this table are looking at trivia and SportsU, which are the two data sets where chain of thought and direct prompting outperformed React and ReWOO. So for whatever reason, these two question and answer data sets, giving React and ReWOO the ability to utilize tools actually led to worse performance than just querying an LLM using direct prompting or chain of thought. And in both trivia Q&A and SportsU, direct prompting actually outperforms even chain of thought, which I think oftentimes I personally feel that kind of a push to add more and more things to agents. I think this is a good reminder that even though you give an agent another tool, it might not actually improve the performance of the agent overall if it's not able to use the tool correctly or utilizes it in a way you didn't expect. Base LLMs are quite powerful and sometimes even outperform their counterparts when they're augmented with tools. So this observation that sometimes tools actually decrease ALM performance led them to perform an ablation study on the effect of incrementally adding more tools to the ALMs. So they start with the same setups for Hotpot QA. So they start with ReWOO and React both having access to 0 tools, and they incrementally add 1 extra tool to ReWOO and React. Figure 5, which is here. So on the left side of the graph at the base, the ReWOO and React have no tools, and there's then a significant increase in the LM's ability once you give it access to Google, but going forward, every subsequent tool essentially either has no effect or significantly worsens the ALM's output. So this specific number of tools and the tools that you give it can be very important choices. And you want to make sure not to provide the ALM extraneous tools that it won't need because it's oftentimes not able to correctly understand and evaluate when it doesn't need a tool. So giving it extraneous tools will lead to a decrease in capability and performance. So quantitatively, they find 20 example questions within the question and answer datasets where the 2-tool ReWOO succeeds, while the ReWOO with 7 tools fails. They also observe 17 of the 20 trajectories that involve tool misuse, such as employing a Yelp query to search for a celebrity. So this ablation experiment indicates that unnecessary tools are harmful to ALMs and by potentially introducing extraneous content. So ReWOO, when compared to React, the current state of the art is relatively, it's important to put emphasis on, is relatively robust to tool failure. Tool failure is common in ALMs at this point. To compare the robustness of ReWOO and React under such a situation of tool failure, they force all tools to respond, no evidence found. Table 3, which is right here, implies that React-like ALM tools, which is the current state of the art, are very fragile when intermediate tools fail. And this is likely because React is an observation-dependent framework, so it goes step by step, and if one step fails, it's not able to continue on or compensate. So it's quite fragile, and failure within any point of the chain of reasoning will lead to a catastrophic failure in solving the task. So on the other hand, ReWOO is less compromised under tool failures and also utilizes fewer tokens. So you can see that here. So when the tool fails with a React, it essentially becomes completely useless. So it gets essentially nothing right. While with tool failure, ReWOO is still able to achieve about 25% of its prior performance with tools. So it's slightly more robust to tool failure. This was also really interesting. They found that the conversation aligning reinforcement learning with human feedback, which is the difference between GPT 3.5 Turbo and TextDaVinci 3. So OpenAI a year or two ago essentially took TextDaVinci 3 and then used reinforcement learning with human feedback to train TextDaVinci 3 to be better suited for a conversation question and answer type scenario like ChatGPT. And they found that RLHF actually decreased the ability of GPT 3.5 Turbo to perform the logical reasoning and foreseeable reasoning that the planner needs in this on ReWOO. So, which implies that the conversation RLHF slightly harms the common sense reasoning abilities of these ALMs, which I was surprised by and I think is a very interesting observation. I think there's, specifically with AutoGPT, I think there's the potential for us to explore the non-RLHF models more, like TextDaVinci 3, on some of their smaller counterparts for some specific subtasks. So in Figure 6, they're comparing GPT 3.5 Turbo and then Alpaca, which is the fine-tuned Llama model, and then the Planner model, which is the fine-tuned Alpaca model. So they find that the Planner module is able to match GPT 3.5, which it has 25 times more parameters, and the Planner module is able to match the much larger GPT 3.5 model in the Hotpot trivia and strategy question and answer datasets. And then furthermore, the increase in accuracy between Alpaca and Planner models implies the effectiveness of the specialization fine-tuning they performed. So qualitatively, for the Planner model, they only use instruction fine-tuning on the Wikipedia and LM datasets, but they observed that when in-context descriptions are provided, the Planner model is able to increasingly use both the calculator and Google to reason. So even though it wasn't trained on instruction datasets for using those tools, the Planner model still had a superior generalized planning ability above Alpaca, which is its base that it was fine-tuned from. So importantly, their results illustrate the potential of a ReWOO paradigm in offloading general foreseeable reasoning into distilled small language models, which substantially improves the system parameter efficiency and scalability. So much smaller models that are more efficient to perform inference on can be specialized for smaller tasks if you know what your domain is going to be beforehand. So there's some really open-ended tasks that the Planner model is not able to succeed on. It's not super interesting. So for the few examples or kind of tasks they found the Planner model fails on, the structure of those tasks implies that a robust augmented language model system should not be built on a singleton or just a single LM. Their findings from ReWOO suggest that a promising approach could be wiring together different LLMs, tools, and submodules into a directed acyclic graph so that each node functions for its pre-designated task originally. I think this could be really promising if you know beforehand what your pre-designated tasks are going to be, and if your pre-designated tasks are generalizable enough, then you might be able to. Although I think using a directed acyclic graph model for the augmented language model might lose some of the generalizability and like on-the-fly reasoning that you get from using a large singleton model. So one of their findings in this paper is that they're able to offload specialized reasoning abilities from foundational LLMs into smaller models. They expect that with a greater number of open domain instructions to fine-tune on, foreseeable reasoning can be even more holistically offloaded to smaller fine-tuned models. They also found that when teaching models how to use tools, the tool representations allowed them to parameterize the whole ALM system and therefore enable end-to-end tuning because they're able to fine-tune the planning module without having to include the intermediate observations because they're just tuning on the generic ability to tool chains together and use them in concert, not the actual outputs of those tools. They also hypothesized that they could apply classical computer science optimization algorithms for graph concurrency optimization to improve the output of the directed acyclic graph structure that ReWOO has. So related works, we've read a lot of these papers. In conclusion, they present ReWOO, which is a modular augmented language model framework that enables multi-step reasoning. And the crucial advancement of ReWOO over the current state of the art is that it decouples reasoning from tooled feedback and observations. So the theoretical decomposition of prompt tokens establishes that ReWOO is able to substantially reduce the prompting redundancy in prevailing thought action absorption ALM systems like React or AutoGPT. their smaller side study within this paper also shows that ReWOO has a relatively robust performance under tool failure scenarios. Their study also unveils the potential for generic reasoning offloading via instruction fine-tuning and specialization of smaller sub-LLM models when compared to using foundational LLMs for all reasoning. So further improvements beyond ReWOO based augmented language systems involve further modular LLM fine-tuning, tool representation learning, and system graph learning and optimization. Questions or thoughts?
Hello.
Hey.
One question. Do they mention any cases where since they generate this plan beforehand with all the steps and all the tools that are involved, do they mention any scenarios when this breaks down because some of the tools, the response of some of the tools in the middle of the plan might might imply that the course of actions should actually be changed? Do they mention anything, any exceptions like this, or it's not really relevant?
No, they don't. They don't offer any examples of that. And I think the reasoning is because the planner module sets out a plan with a bunch of small actions and then the responses, but each worker that is executing those actions is only getting one action and only returning one response. So there's no component of ReWOO that's able to evaluate whether the evidence that's returned from the worker should or actually lines up with the plan that the planner provided. The solver is just given the evidence and the plan after they've all been essentially computed, and then is asked to solve it. So there's no high level, essentially like supervisor module that's able to observe that failure or tool response within the chain of tasks to maybe go a different way or change the plan. There isn't a component of ReWOO that has that capability.
Oh, I see. You mean that since the plan is generated, it's carried out no matter whether there could be a better plan if we changed it in the middle of the evaluation. It is generated and carried out. Yeah, makes sense. And I also see that these tools, they form a graph because one tool can generate output, and it is already planned that this output will be fed as input to some other tool in the plan, and this is some kind of graph that worker computes, like example number 3 depends on example number 1, for example, and this is how workers do it. They evaluate example evidence number 1, feed it to evidence number 3, 3 as input parameter.
Yeah, exactly. The plan the planner agent comes up with is essentially a graph linking together nodes, their workers. Mm-hmm.
I see. Yeah, that looks very neat. Got it. Thanks.
Yeah. I guess anyone else? If not, we'll be back on Monday, hopefully.
Thank you.
Thank you.
Thank you.
Yeah, thanks. Super
Bye.
cool. Later.